Good morning, my name is Jim. I work for NASA Ames Research Center, and I'm glad to be here today. I want to talk to you today about CubeQuest Challenge. So, any questions? Here we go. What is the CubeQuest Challenge? It's a competition for non-government CubeSat developers to win an opportunity to launch on the EM1 mission, getting their CubeSat to the moon, or if they can achieve a range of 4 million kilometers, to perform some communications objectives, last the longest, and have an opportunity to win prizes from the federal government. It's only open, unfortunately. Well, prizes are only awarded to U.S. entities and not available to non-U.S. entities, but you can still compete in the challenge.
America first.
Why are we doing it? Well, the question came up in about 2013. It was decreed that there would be space for secondary payloads in the EM1 mission, which is going to be launched on the SLS. There will be 13 slots for 60-sized CubeSats. The question was, can we do something interesting and useful if we offer those to the public to compete for that payload space? Well, we all know that CubeSats have their advantages. Small satellites can do things that large satellites can't do. We wanted to see what would happen if we offered these spaces to the creative people who we call citizen-inventors, to see what they can do with them. As you all know, because you're here today, and I don't need to tell you that there are things that we expect CubeSats to be able to do in deep space, but currently they require some development to the state of the art. So the question was, this is it. Can a prize challenge to citizen inventors make use of the EM1 launch space to advance CubeSats so that they're capable for unique and more affordable space missions in deep space? So that our answer to that question is the CubeQuest Challenge. Government challenges have a long history. There are many different examples on this page. I wanted to bring up the one that's called in the year 1714, the British government offered a prize called the Longitude Act for anyone who could develop a portable and practical solution for determining longitude at sea. And because there were there was the need for accurate navigation. And an amateur clockmaker named John Harrison invented the marine chronometer and won, at that time, 20,000 pounds, which would be worth over 2 million pounds in today's currency. So that's an example of a government challenge that was successful. The Centennial Challenges program is NASA's government prize challenge program. And they have currently 5 challenges that they're administering, one of which is the CubeQuest Challenge. This is the space that's available on the EM1. The CubeSats go in these deployers that are 6U in size. They are circumferentially arranged in the ring and in the upper stage of the ICPS, interim cryogenic propulsion system. So this is just before the Orion, just after the Orion capsule is deployed in its translunar injection trajectory, the ICPS does a collision avoidance maneuver and deploys all 13 of the secondary payloads. There are a number of stops you can choose to go along. They call them bus stops, where the sequencer will eject the 60 CubeSats along your way to the moon. We invented the CubeQuest Challenge by thinking about design reference missions, which would be useful for future science and exploration. That could be accomplished by small satellites. And then we determined what capabilities of CubeSats would need to be grown in order to accomplish these design reference missions. We arranged them in terms of, we know that we need things like better propulsion, we need long-range communications at higher data rates, we need a variety of different capabilities, which are the ones that we want to design the rules for the CubeQuest Challenge to award prizes. And these are what we arrived at. We are going to award a prize if you can achieve lunar orbit. We're awarding prizes for high data rate, large data volumes integrated over time, and the farthest communications distance. and a prize for surviving the longest in the deep space environment, either while you're in lunar orbit or at the range of 4 million kilometers. We established those into a series of rules. It took more than a year to actually document all the rules and make them so that they were enforceable rules so that we could observe the operations and ensure that there's no gaming of the system. We did a couple of requests for information from the general public about draft versions of the rules, and these are what we came up with. You can see the prize amounts for first a series of 4 ground tournaments where we will, they're kind of like NASA engineering reviews, where we would award small, modest incentive prizes for to encourage the development on the ground, culminating in the 4th ground tournament, which is the down select for the final 3 that will fly on the EM1 mission. The Deep Space Derby is the one where you go to 4 million kilometers. It's very similar to the Lunar Derby, in which you have to do your achievements while maintaining a lunar orbit. And these are the prize amounts for data rate, data volume, and longevity. The rules also require that you adhere to safety requirements for the SLS, and that there's only about 26 rules in the CubeQuest challenge. They have subparts, but they're designed so that we can ensure that the challenge is administered fairly and that we have observability into the performance of the teams. There are 5 judges in the CubeQuest challenge. Over time, we've had replaced 2 of those judges, so altogether we've had 7 different people serve as judges. 3 of them currently are from NASA. There's 1 retired member of industry, and also we had a member of the Air Force Research Lab who served as a judge, and 1 university associate who was a judge. They're backed up by teams of subject matter experts that can do things like for the ground tournaments. They will analyze all the paper submittals for the designs of the CubeSat and advise the judges on things like communications link budget margin and propulsion margin and these kinds of things. The scores are based 40% on the judge's assessment of your likelihood of mission success and 60% on compliance with the rules and with the SLS safety requirements. There were originally 13 teams that competed in ground tournament number 1, which was March of 2015. And the ground tournaments have been spaced every 6 months since then. The team names that are in bold font are the winners of the 5 winners of the first ground tournament, each of the ground tournaments. The second ground tournament, about 6 months later, there were only 10 teams. This is through attrition. There was not a down select during the ground tournaments. Anyone can join up with the CubeQuest challenge at any time. 7 teams in ground tournament 3, and currently we're in the middle of ground tournament number 4, where we have 5 competitors. And we will announce the selection of the 3 winners of ground tournament number 4, who will be named to go on the EM1 mission next week, Thursday. The 5 teams that are competing in ground tournament number 4 are listed here. The color, I don't know what color it is, it's sort of a yellowish, goldish color, are the ones that intend to go to achieve lunar orbit. The other 2 will only do the deep space part of the competition. I've highlighted some of the team information here that I found interesting, and not enough time to go over all of the emerging technologies that are coming from the team's proposals, but there's a lot of interesting stuff. I just wanted to point out some of the highlights that I found interesting, including how the teams chose their team name. Cornell University, these are in alphabetical order, by the way. I don't want to favor any of the teams. We like all of our children equally. And also Wes Baylor is going to speak later today about his competition entry. Cornell University are the Cislunar Explorers. Not much you can say about the Cislunar Explorer name. It's pretty straightforward. They're part of the SSDS, which is the Space Systems Design Studio at Cornell. And one interesting thing about their unique in this regard. They're planning to do, their propulsion system is based on hydrolysis of water, and they will split their 6U CubeSat into two L-shaped, one by two L-shaped sub-CubeSats that will then they spin and rotate to help separate the hydrogen and oxygen from the water. I mean, to separate the gas from the water, and as part of their also stabilization system. It was a unique design, and we checked the rules to make sure it was okay that they could operate two rather than one, and it's in compliance with the rules. So it's a unique mission concept. University of Colorado at Boulder called the CUE3. That stands for the E3 is Escape, Earth, and Explore. So that's E-cubed, actually. E-cubed. They're a team of university students, and shown there some of the characteristic features of their CubeSat. Team Hyde is put forward by Ragnarok Industries. They decided to go with a Norse god mission name concept based on an earlier experience they had as they were interns at Goddard Space Flight Center. They worked on a mission that was called the Dellinger, and that gave them the idea to continue with the Norse god theme. I think, let's see, I wrote it down because I'm not up on my Norse mythology. The Ragnarok is a concept in which the old world is washed away by the new. It's the idea that we're leaving behind the conventional spacecraft paradigm, and we're now going into this new world of smaller and non-traditional spacecraft design. The Heimdallr roughly is translated as the god who is the one who illuminates the world. There you go. University of California, they are with the students of the Exploration and Development in Space. I don't know what the Tritea stands for in their mission design. So sorry I don't have that information, but there's a picture of the team. Team Miles, as I said, Wesley is going to speak about his mission design later today, but I really liked the origin of their team name. It comes from the Robert Frost poem, Stopping by Woods on a Snowy Evening. If you remember, there's the final line that says, and miles to go before I sleep, and miles to go before I sleep. Alluding to the idea that these little CubeSats have a long way to go into the whole expanse of space. These are some of the emerging technologies that are coming from our teams that are proposing novel designs or who will be using commercial off-the-shelf CubeSat components for the first time in deep space, getting a TRL 9 qualification for some of these COTS parts. I think that it's interesting that they're working in, across various bands of the communication spectrum. Some of them are going to be building their own ground stations. Some of them are relying on NASA's Deep Space Network to make the rules equitable for everybody. We require that they pay for Deep Space Network use, even though they could be considered conceivably a NASA mission. We ask that they pay for their DSN antenna time so that we can encourage those who will be using their own ground stations. More details about the communications technologies that are in development. In the interest of time, I'm not going to go into the details, but these slides will be available in the proceedings of the conference. Propulsion, there will be some commercial off-the-shelf propulsion, but also one team is going to be using additive manufacturing to 3D print their own thrusters for a green propellant. So, as I mentioned, the winners are going to be announced at a conference that's next week at Ames Research Center. You're all welcome to come and attend. We'll be announcing the 3 that will be flown on the EM1 mission. There's the URL for the sign up for the conference at Ames. This also be done in conjunction with the Small Satellite Technology Program and the Small Satellite Systems Virtual Institute at NASA Ames. So there will be other speakers that will be coming, members of NASA leadership, as well as a variety of mission developers for the EM1 mission and other speakers will be there for the 2-day event. So the next steps are going to be that the teams will be putting together their satellites and testing them. The delivery of the payload is currently scheduled for April of next year, though that may move since the launch date has moved to the right. Teams may choose to find their own way to the moon or deep space. They don't have to fly on the EM1, and because of the delay in the EM1 mission, I'm hoping that's going to open up opportunities for third-party launch teams to compete in the competition. There's sort of a cartoon of the timeline. The whole competition ends exactly 1 year after EM1 launches, regardless of whether you have a third-party launch or not. So I'm out of my time, and that's the end. I don't know if I have time for questions. Yeah.
Any question?
That's a very significant challenge, of course, and presumably inspires many in the US to propose the concepts. Given that the launch is then 2019, you said, and the delivery next year sometime, the selection is next week. So could you comment a bit on the maturity of these different concepts? Are they going to be ready on time? It's not a lot of time to get the spacecraft together.
Yeah, so we've had to compress the what normally in a NASA mission would be, phases A through D, into a just under 2 years of the ground terminals 1, 2, 3, and 4. There were programmatic reasons why we were required to name the 3 that we're going to fly on EM1 as soon as possible, because they still have to do things like VSN compatibility testing and a variety of payload safety reviews, and so because of the lead times required, we had to name the 3 for the EM1 mission in June this year. There will be, the judging includes an estimation of the likelihood of mission success based on the current status of the teams, and they're now at critical design review phase. They're just putting together subsystems and testing them. But we asked the judges to look ahead to planned schedule margin and planned integration and test and contingency plans and things like that to include in their judging an assessment of how well they would deal with unexpected eventualities between today and when the payloads are scheduled to be delivered in April of 2018. So there's always the possibility that something could go wrong. There's always that possibility on any mission. Who knows? That's just part of the experience.
It will be around CDR level right now.
It should be around. They are around CDR level, the equivalent of CDR level.
Just to ask maybe a second question, are there any free slots still remaining on the EM1?
No, EM1 is fully booked. And, if somebody drops out, it wouldn't be one of our CubeQuest competitors, but if somebody does drop out, I don't know how they intend to fill in the vacant slots. So keep your eyes open, maybe there's another opportunity.
They're all there left to sell their slots.
Sell their slots?
They win the slots.
The Space Launch System program is keeping a pretty close eye on who's doing what and who they're allowing to get into the launch vehicle. And they've already been through a year's worth of payload safety reviews and very stringent requirements for integration with the launch vehicle, and it's a very rapid process.
I'm not hearing that. Okay, thanks.
Are you going for something similar for the EM1?
I hope so. EM2 is a long way away, and I haven't heard any talk about what they will do for secondary payloads, but the secondary payload space is now an intrinsic part of the Space Launch System. So I would imagine there will be something, whether there's an open public competition for space, I don't know, but I know there will be space for secondary payloads in EM2. Maybe there will be a competition.
Any more questions? Okay, well, thank you very much.